Welcome to Business Calculus. I hope you can enjoy and learn some interesting things this semester, hopefully things you can apply in business settings. For this very first video, we're going to look at graphing functions. There are some basic functions that it's good to know the general shape of and what's happening. That will make things easier to understand when we're going through and doing the business calculus problems. One of the first ones is simply working with straight lines. Now, during the other lessons, we will get into slanted lines and how to graph them. But students, I found, sometimes get confused when they have horizontal or vertical lines. This is a vertical line, just going straight up and down. And this particular equation is set for x is equal to 6. If you look at this, you realize that 6 is the value for x at every location on this line, but the y value changes. Whenever you see an equation like this where x is equal to 6, that means the x value always has to be equal to 6, hence the straight line up and down. For any y value, the value of x is 6. That's what makes it horizontal. Now, in general form, we'll oftentimes see this as x is equal to a, where a could be any number. In this example, x is equal to 6. The a value would be 6. If the a value was 12, then it would be x is equal to 12. So if you ever see a formula like this, and it's talking about graphing it, and you see x is equal to some value, it's just a vertical line, with that value being where the vertical line is at based on the x-axis. As you might imagine then, this horizontal line represents when all the y values are -3. As you can see, as you look at the line, all the y values are on -3, regardless of what the x value is. At -10, -3, the dot goes down at -3 on the y-axis. At 0, -3, the y value is -3. So that creates a horizontal line this way. So whenever you see an equation where y is equal to some value, that simply means it's going to be a horizontal line at whatever value b so happens to be. If it's 5, then the y value would be up at 5, and it would be a horizontal line where all the y values are 5. In this function, this is a polynomial, and it forms a parabolic shape, or a parabola. And you're probably familiar with this from earlier classes, where you say y is equal to x squared, and that forms this graph. This is something that's helpful to remember throughout the course and throughout other math classes that deal with parabolas. This is the basic shape. It's good just to be familiar with this, so when you see it, you know you're dealing with an x squared in some way. As you'll notice, the very bottom of the parabola, the vertex is at 0, 0. And one way to think of this equation, even though it says is y is equal to x squared, you can think of it as y is equal to x squared plus 0. That'll help us in just a second. Now, if we were trying to graph y is equal to x squared plus 4, that plus 4 is going to move the parabola up 4 spaces on the y-axis. So the green line would be graphed x squared plus 4. This is just helpful to know how the graph shifts or transforms, and having x squared and then plus some number will move it up. If it's minus some number, it will move it down that number of spaces. But it just simply shifts it up and down. If we had y is equal to x squared minus 5, again, the minus 5 is going to move it down, and it will be down touching the very bottom of the parabola. Will be down at y is equal to minus 5. Now back to the standard y is equal to x squared function again. If you have an equation where you have y is equal to the quantity x plus 3 quantity closed squared, that's going to move the point of the bottom point of the parabola again. And sometimes students find it surprising, but it's just something to remember, that when it says plus 3, and the plus 3 is inside the parenthesis and everything's squared, when it says plus 3, it moves it in the opposite direction that students think it should go. It's going to move it to the left, or shift it, what students think of as, oh, it moves it to the left 3 spaces, like minus 3. So if you think of it that way, just think of the fact that you want to change the plus, whatever sign is there, to the opposite sign. If it's plus, make it minus, and move it 3 spaces to the left. But the general concept is whenever you have x plus some number, it will move that number of spaces. If it's plus, it's to the left. If it's minus, it's going to move it, as you can imagine, to the right. But students oftentimes think of this as being moving it to plus. It's just the way that it is. Now back to our same original equation of y is equal to x squared. If we combine these together, as you can imagine, this equation, the x plus 3 quantity squared, is going to move the center of, or the vertex of the parabola to the left 3, and then it's going to move it up 4. So that's combining what we learned earlier on the past 2 slides. Whenever we're doing this, whatever's inside the parenthesis moves it the opposite direction you think it should. But if it's after the x squared, the quantity x squared, and you're just adding a number or subtracting a number, then indeed that will move it up 4. A negative number will move it down. So if we were to look at y is equal to x minus 2, the quantity squared, minus 5, that is going to shift it to the right 2, because it's minus 2, to go the opposite direction you think it should. But then the last number that's by itself is a direct moving it down 5 spaces. So hopefully that gives you an idea for what's happening and how equations will look, and how a graph can be drawn from the formula. And looking at a graph, you can also find the formula, knowing these general equations, which can be helpful. Save you some time in the homework. Now looking again at y is equal to x squared, if we have a negative in front of the x squared, if you remember your laws of exponents, because there's no parenthesis there, it's going to be minus, and then you take x and square it. So what that's going to do on the parabola is to flip it over the x-axis. Basically, instead of opening up like the blue line, the red line the red parabola opens downward. So whenever there's an x in front of the x squared, it's simply going to invert the parabola and make it go down. Combining all of this together, if we had a negative, the quantity x minus 2 squared minus 5, when we do that, as you can see, the negative will invert the parabola. The minus 2 will shift it 2 to the right. We think of it the opposite way again. 2 to the right, and then down 5 for the minus 5. So if you're drawing that, you'd put your point at this 2 minus 5 and draw a standard parabola shape downward instead of upward. Another very basic function that we see, especially in calculus, is y is equal to x cubed. It looks like this. You look at it, you say, well, it kind of looks a little bit like half of a parabola on the right, and the left side of it looks just like it flips over. Well, it's kind of true. It's not exactly a parabola. Obviously, it's not a parabola because both don't go the same direction. But half of it will look similar to a parabola. The standard function like this, it's not quite as wide as a standard parabola, so you have to be a little bit careful in drawing it. So if you're starting at 0, 0, when you go to point 1, you're going to pair that off. The y value would be 1. But on a parabola, or x squared, the x value of 2 would yield a y of 4. However, since this is x cubed, an x value of 2 would yield 8. So it's going to go up faster than a parabola, and hence it'll appear skinnier when you look at that half side. The simple way to draw this is just to remember that it comes up from the bottom and kind of curves into 0, and then does the same thing on the top part of the graph from when x is greater than 0. It just looks like this. When we're working with moving the graph around, as you could imagine, this is similar to x squared. When you have y is equal to x cubed plus 4, it's going to shift the graph up 4 places, just like it does with x squared. When you have y is equal to x cubed minus 5, that's going to shift it down 5 spaces, just like with the parabola. When we use, again, here's the graph of y is equal to x cubed. Just like before, when you have the x plus 3 in parenthesis and it's cubed, that's going to shift the graph. And as always, it's the opposite way that you think it should go. That whatever's inside the parenthesis, if it's positive, we'll shift it in the direction to the left instead of the right. And it shifts it down 3. And if it's negative, it's going to shift it to the right too, so the graph would shift over this way. Hopefully this is familiar. And of course then doing the same thing with all these together. When you have y is equal to x plus 3, the quantity cubed plus 4, that's going to shift it down 3, but then move that center point up 4. So it's a little bit more complex, a little bit harder to draw, but it's the same concept. If we had y is equal to the quantity x minus 2 cubed minus 5, that's going to shift it to the right 2 and down 5. Now back again to the y is equal to x cubed. If we put a negative in front of this, the same kind of thing happens as with the parabola, but it seems a little bit weird. It's just going to flip it over, so to speak. The red line starts now at the top instead of the bottom and comes down and curves into 0, and then as it approaches 0, then as it goes positive, the x values go positive, it's going to go down. So the blue was the original one. The red curve graph represents the negative x cubed. So as you can see, it's just like it gets flipped over the x-axis. And if you're going to apply all of this together, when you have y is equal to negative the quantity x minus 2 cubed minus 5, then it's going to invert it or flip it over the x-axis. And that's what the negative does. The minus 2 means it's going to shift it 2 to the right, the opposite direction you tend to think it should. And then the minus 5 will move it in the direction, the y direction you think it should go down 5.